Moving on, we also have with us another Walchand alumni, Dr. Rucha Natu from the batch of 2012 of Mechanical Engineering. She completed her PhD in Mechanical Engineering from Clemson University, USA in the year 2018. While at Clemson University, she has an experience of being a graduate teaching assistant for 4 years and also has worked on various projects in the field of microfluid and cell sorting. Currently, she is working at Food and Drug Authority in United States and studying performance characteristics of microfluidic medical devices. So now I request Dr. Rucha Natu ma'am to enlighten the future engineers about the experience and guide us about the career opportunities in the US. Thank you.
Hello. Hi, thank you for the introduction. Thank you, Sejal, for sharing my presentation. I am Rucha Natu and I'm currently working at the US Food and Drug Administration. I work in the devices, Center for Devices and Radiological Health. And as he mentioned, I am a student of Walchand. This is a small introduction about me. I graduated from Walchand in 2012. And after my graduation, I worked at Cummins Engines Limited for 1 year. I worked in the engine fuel and filtration department. It is in Pune. And after that, I came to US to pursue I basically came to pursue my master's, but eventually things happened such that I ended up pursuing PhD. So I will tell you more about my experience. My experience is mostly in microfluidics, electrokinetics, then material sciences. I also worked as a teaching assistant. I taught a few courses when I was as a PhD student. After my PhD, I worked as a postdoctoral fellow for 1 year. And following my postdoctoral experience, currently I'm working as a visiting scientist in the Center of Devices and Radiological Health. I'm working as a I'm working as a microfluidics researcher as well as an evaluator for medical devices. I will tell you more about all these different interesting areas as we go further. Can you go to the next slide, please? Yeah. So I wanted to talk about why pursuing higher education is important, according to me. Since B.Tech in a college like Walchand gives you very good, very strong fundamental knowledge, it also helps you build the basis for your career. But this just gives you a peek into the world of technology or in the world of engineering. I feel it is important that you go beyond this to learn more about engineering, to broaden your avenues for career, broaden your options, find more options. I think by the time you complete your bachelor's, you're more mature to make a proper decision to know the field which you want to pursue. It also helps you get a good job profile and title. Of course, it comes with higher salary, and it also gives you a slight edge over others. So on the right side, I have put 3 different points which have been guiding points for me in my life. And when I was a 3rd-year student in Walchand, one senior student had visited us and he drew this Venn diagram on the board. And he told us that there are 3 things which drive your career: passion, strength, and of course, compensation, because you need money. So I feel this is something I have followed throughout, something that is your passion. So for example, working for people or doing something good for people helps me get motivated. That is my passion. My strength is my engineering knowledge or my liking towards engineering. And thirdly is compensation or the salary. So these are the 3 things which came together in the field which I am working for me. And that is why I chose this field. Second important goal which I follow in my life was given to me by my current manager. She always told us that we should choose progress over comfort. Once we start getting comfortable in life, for example, you get a job after B.Tech, you start earning some money and you get comfortable, you lose the urge to go ahead and make progress. So you should always strive for progress instead of striving for comfort, at least in your early years. So this is something which she told me and it resonated with me. This is something I always follow. And thirdly is a famous line by Steve Jobs, which I always have followed in my career and I try to follow it. That is, stay hungry, stay foolish. Which means you should always be hungry to get more knowledge, to learn more things, keep your eyes and ears open for knowledge. as well as you should always stay foolish. You should always, you should never have ego for whatever you have learned. So this is something I just wanted to share with you before I go further and talk about higher education. Thank you. So when you look at the different degrees or courses which are pursued in US, Masters or MS is the most common course which most of the students come to United States for. And there are a few students I know who also come to pursue ME. ME is mostly a non-thesis course where you take you learn different subjects. And this course is more oriented towards applying your engineering skills, whereas MS is more oriented towards learning science from your engineering. For example, in MS, you will cover more principles of thermodynamics. You will look at the different derivations. But with ME, you will look more at the application side of things. MS also comes with different options. There is an option for doing a thesis, or you can do a non-thesis work where you can do several projects as well. I did a thesis, so I will talk more about thesis. When you do a thesis, you also have an option of working with a professor. This gives you an insight into different researches which are happening in the university. You also get to do some research on your own. And this also helps you get some scholarships or funding. And this is something I'll also talk more about. And non-thesis option is also a good option because it helps you complete your degree in, say, 1 or 1.5 years, where you can also pursue an internship. Another important factor with doing non-thesis is you can go ahead and look for a job very quickly because you do an internship, you have more job opportunities coming in. Since I did a PhD, I will also talk more about what is PhD or why one should do PhD. So when I came to US, my focus was clear. I wanted to do masters and I wanted to get a good job in a good company, a multinational company. When doing research, I realized that this is something I like. I like to answer questions which are posed in science. I like to look at different questions which can change the future. And that is something which motivated me to go further for a PhD. There are some things which you require in your temperament if you are thinking about a PhD. I agree that when you are a student and when you are learning in, you are in an engineering college, PhD is something which is a far-fetched goal. So you don't always think about it. But I would say it is a good thing to give a thought to this early because when I was in college, I never thought about PhD. I only got exposed to it after coming here, but I'll give you some information. So hopefully at least a few of you will be motivated to answer some questions in science and look at PhD as an option. Another good advantage of doing PhD is you can be in the university for 4 or 5 years. You can see the atmosphere or the teaching in the university very closely. And of course, PhD is funded, so you don't have to pay from your pocket. You always get a scholarship. So you're not paying for anything. So your education is basically funded. It also saves you a lot of money. So this is another advantage, I would say, of doing a PhD. But of course, it takes a lot of perseverance and you have to have a lot of patience because sometimes some of your friends who complete masters in, say, 2 years, they go and they get jobs in different companies. But you are still working in your lab, you're still pursuing PhD, you're waiting to get the title of a doctor. It can be challenging. So it is, again, it is a matter of temperament. There is an option of doing a direct PhD also. A lot of people also do their masters in India and then they come to US for PhD. I have few friends who have done that. Some people also go to different labs for internships after doing bachelor's and then they directly come for PhD. That is also an option I have seen some people taking up. So if you are interested in exploring research, you can always look at different labs in India. They always like to take interns. And this can also give you an opportunity to look at research. Another important area is MBA. MBA is also pursued by students who have a business acumen or a liking for business. I have heard that pursuing MBA in US is quite expensive, but I'm sorry, I don't have much knowledge about MBA universities. And I would say it is though useful if you pursue MBA with some job experience, because it definitely helps you in your career. I see a message here from Dabir sir. Namaskar sir. छान वाटलं तुम्हाला बघून इकडे. Sejal, can you go to the next slide? Okay, so before I go a little bit into research which I have been mentioning, I'll quickly talk about how to prepare to come to US. I think Gaurav and Amrita are going to stress more on this because I saw that in the slides. But till then, let me just tell you briefly about what are the different things you need to do to come to US. GRE and TOEFL are the primary exams which you have to give to come to US. A lot of people think, I mean, even I thought about it that way, that GRE is an exam for English. Why do you want to study English if you're an engineer to go to US, right? I mean, that's a very valid question anybody can have. But imagine that universities in US are looking at applications which come from all around the world. And it is difficult for them to evaluate a person who comes from Walchand, or a person who comes from MIT, or a person who comes from a college in Russia. So in that case, GRE is a common platform which they have defined to evaluate all the people. Another important thing is US universities believe that people who have analytical minds like us, engineers, are very good in analyzing things. So even if GRE is an exam of English, if you look closely, a lot of questions in GRE are very, very analytical. You have to look at very subtle differences between different words, or you have to analyze the information in a passage. So these questions are designed in such a way that your analytical mind is challenged. And that's why GRE is the exam which US universities have preferred. TOEFL is another exam which is conducted, but if you are good at speaking English, or if you watch some English movies, I think TOEFL is a very easy exam. Academic credentials are another important factor which are looked at during admissions in US universities. Of course, Walchand is a very good college, so you all are very smart people. So I'm sure you all have good academic credentials. US universities also look at job experience or project work. And in this, a lot of resumes which I see from students, or a lot of students who contact me with their SOPs or statement of purpose, they always try to put project experience from big companies, or, if any awards they have got. US universities are not interested in looking at any awards which you have, unless they are international awards. They are more interested in looking at what project work you have done. Even if you have worked for a startup company or a small foundry in, say, Sangli, versus you have worked in Tata Motors, what work you have done, what project experience you have is more important. So they are not looking at big names. So instead of putting big names of companies in your project, trying to put good project work, quality project work is more important. That's something I would say about writing a statement of purpose, or for SOP in your preparation. And thirdly, the most important thing which challenges all of us equally is the financial preparation. Of course, since the economic conditions in US and India are so different, everything we get, we have to multiply by 70 or 75 to convert it to Indian money. So that is why finance can be a challenging issue. A lot of times I have seen people who work in India for 2-3 years, save some money, and then they apply for US universities. Or another thing is, when you apply for universities, if you talk to people in advance, if you are able to communicate and see the scholarship avenues in a particular university, it becomes easier to apply to such places and look for scholarships or get scholarships. If you are doing a thesis, you have more options to get scholarships. If you have any particular questions about scholarships, I can definitely answer to them. I'm not covering much about it right now, because I think Gaurav and Amrita are also going to brush on that topic. But I'll definitely answer if you have any specific questions. Can you go to the next slide? So one of the very important things about studying in US is being able to select a good university. It is very important that you select a proper university before you come here, instead of regretting after coming here. I have seen students who come to US with big dreams, but the university is not good or it's very expensive, and they end up regretting it. So again, I have a Venn diagram. I'm very fond of visuals, so I'm trying to use more Venn diagrams I see. But if you look at it, good education, university being affordable, and having good opportunities are three important things which I would look in a university. A lot of times people also have questions between private and public universities. Public universities are slightly cheaper than private universities, but some private universities also have avenues for scholarship. So if a private university is providing you a scholarship, it is also a good option to look at. Length of program is also very important, because sometimes MS courses are 2-year long courses, or some courses are just 1 year or 1.5 year long courses. In shorter courses, you definitely save a lot of money on expense, on fees, and that is very, very useful. Another thing which I would look at is the place where the university is located, because a lot of times some universities are located in big cities like Los Angeles or Chicago or New York. These cities are already very expensive. Living in this city is very expensive, and that's why when you are a student, it's very difficult to afford them. Whereas if you live in small college towns, which are close to cities, but they are still small towns, maybe small towns like Sangli or even smaller than that, you can save a lot of money. So for example, the university where I studied, it was a very small town. It's like ekdam American gaon, chota. So I ended up saving a lot of money in my grad school because of that. So I would definitely recommend you to look at the expenses and the standard of living of the place, because even if you live in a small town, you still have opportunities to go for jobs in bigger cities, because job market is not restricted to like super local areas. So I would suggest that you consider this point. Weather is another important point which I think many people like to consider, especially if you don't like cold. You should definitely look for a university which is in the southern part of United States, because northern states in US experience severe cold, and that can definitely affect your health. It can also affect your learning abilities. And another very important point I would say is talk to the students who are currently studying in the school. Because if you talk to your seniors who have graduated 5 years ago or 6 years ago, they might not be able to tell you the current details about the scholarships available or funding available. But the student who is already studying there has some idea about what is the funding situation, because funding situations keep changing all the time. Professors apply for different grants and they keep getting fundings for 2 years, 3 years. So it's very difficult to know about the funding situation of that lab at that time. Also, an important aid is looking at the websites of these universities. If you go to the departmental website of these universities, so let me talk briefly about my experience in the university where I studied. So my state, it is a state which is not one of the expensive states, because I wanted to study in a place where I don't spend too much money. And my university's name was Clemson University. I'll talk about how my journey began in the university. So obviously, like I mentioned, I gave the GRE exam, I gave the TOEFL exam. Dabir sir and Mane sir were kind enough to give me recommendation letters as well, which helped me get good school. And after I joined for masters, I started working with a professor because I always wanted to do some research. I had studied courses or subjects in Walchand anyway. So I wanted to get some experience on research because I had always heard about this term research. And I really wanted to know what it means to do research or what exactly is research. So I was very curious about it, and therefore I opted for thesis option. Fluid mechanics and thermodynamics were my favorite subjects in engineering. So I wanted to do something related to those subjects. So I also chose a major which was in thermal and fluid sciences. So most of my courses were in thermal related to thermal and fluid sciences. Also, when I started working with my PhD advisor, I mean, he was the professor I started working with. You can see him in the picture here, this person. So when I started working with him, he had some research opportunities. He had some small projects, and I worked on those projects. He was happy with my progress, so he started giving me bigger projects to work on. And as time progressed, he had some funding for a PhD student. He had some scholarship money available, and he thought I was a good candidate to go for a PhD. So he talked to me about it. I was enjoying my work, and therefore I decided to go for a PhD. So instead of doing a master's, he told me that if I go for a PhD, it might help me to complete my PhD quickly. So that was an option which I opted for. But this decision I took after working with him for 1 year. After working with him for 1 year, I already knew like how my work was, how my liking was to the field. A lot of people take this decision of going to direct PhD when they are in India, and that decision might end up backfiring because when you are in India, you don't know how the lab is or how the professor is. Sometimes if you're not able to work well with the lab or with the professor, it can be a very difficult decision. Therefore, if you want to take such a decision, I would definitely suggest that you come here, take some research experience, and only after that make a decision to go for PhD. And since I got scholarship opportunity, it helped me pay my fees because of my scholarship, I didn't have to pay any more fees. And it also was useful. Oops. Sorry. It was also useful because it also gave me a chance to become a teacher. I wanted to teach, and this my professor paid my fees as well as he used to give me monthly salary. And in return of this salary, I used to teach some courses for undergrads. And during my undergraduate teaching years, I got to see how the US educational system works. What are the different good things about the US education? These are some of the amazing things I'd like to share with you. And also, I'll talk a little bit about my job experience. Before I go to my research, I think there is one slide which I missed in the earlier presentation, which I would like to cover. Sorry for the inconvenience. Okay. So you must have heard a lot of people talking about pursuing masters in US or pursuing PhD in US. So I want to tell you why US universities are so hyped and why the opportunities in US are so coveted, why people want to come to United States. So these are some of the things which I think are big advantages of American universities. And I'm very happy to see that a lot of these things are also being implemented in Walchand College. When I was talking to Dabir sir earlier, he told me some really nice things which are there in Walchand now, which is really amazing. So some of the things which I like about American universities are that the professors have freedom to design courses. So even if a syllabus is set, professors can use their own methods, use their own innovations to come up with courses.
Launching a choran. Mobile.
So, for example, a lot of mechanical students, or I think even students from other branches, you all must have taken engineering mechanics, right? So for engineering mechanics, one of my friends who is a professor, she loves baking and she makes these big towered cakes, like how wedding cakes are with 3-4 layers. She makes all those amazing cakes. So she used this baking information or her liking for baking into her engineering questions. So when she gives questions to her engineering mechanics students, she asks them about, if this is a cake, I'm carrying it over a slope. How will you calculate the coefficient of friction so that the cake doesn't fall? This is an example. So this is how they make learning more applicable or project oriented. Another nice example, which I always give
Recording
to a lot of people
stopped. Recording in progress.
Okay. So another example which I always give to a lot of people is about the, I think you might have studied it in theory of machines. I studied it 10 years ago. So we have a lot of questions about linkage mechanisms, where you have 4 link mechanisms or 5 link mechanisms, and where one link moves and you have to calculate how the other links move accordingly. This is a very specific example to mechanical engineers. So I'm sorry if some people from other branches are not able to understand, but I hope you get the idea of what I'm trying to say. So this, in India, we used to do this by drawing diagrams on paper. I don't know how you do it. Maybe you guys use softwares now, but I saw that the professor gave these students some project. He told them, you have a Coke can and that has some Coke, and you are going to use the linking mechanism or the linkage mechanism to pour the Coke from the Coke can into the glass. So they have to design this mechanism. They have to make a drawing, they have to do the calculations, and they also have to build a structure or a linkage where such a project can be done. So this is how they motivate project-oriented learning. They teach the same courses that we have, but they're more project-oriented or more applicable. A lot of these activities are done in groups. So a lot of people are involved in discussions. There are a lot of group assignments, as well as you guys have major and minor courses which you can take. That is also there in US, even in grad school. I mean, when I was a mechanical engineering master student, I took courses from statistics, mathematics. I also took a course which was in sports engineering. I also took a course related to scuba diving or karate. So you can take a lot of courses in the university. So there are several nice opportunities which people can use in these universities. Also, I would like to say that another important thing I like about American universities is the exposure to multiple cultures of the world. When I was a student, I got to meet people from many different countries, and this experience is very enriching. So when we are in India, or even when we go out, of course, we are always proud of our country. We are always going to talk about our country. But when you also get to see other countries, you learn a lot of things from these people. You see different perspectives. For example, people from Italy or people from France, their mathematics is very good. Their engineering knowledge or mathematical knowledge is extremely good. So these are some of the things I learned from them. Chinese students are extremely hardworking. They can work through the weekends and weekdays. So there are a lot of things I learned from a lot of people around the world. And then sometimes you meet people from some African countries. You also realize that you are so blessed to be an Indian. So there are a lot of nice experiences which you get culturally. You also get to taste different foods. The campus life in US is very vibrant, very nice. Universities have very nice recreation centers. You can participate in a lot of sports. You have an amazing library facility. One thing I like about American libraries is all the libraries of different American universities are connected together. So if you go to a library and you're not able to get a book, and you tell the librarian, he will order a book for you from other university. So, which is really helpful because you always get books from all, I mean, the book is going to be available somewhere in the country, right? So you always get a book whenever you need, and you can take any number of books you want. There are nice study spaces in the libraries which you can use. Very, very nice, vibrant community around you, which helps you grow as a person as well. So, sorry, now I'm going to go back to my original slides of research. I'm going to quickly talk about my research because I don't want to take too much of your time as well. And since I have been mentioning so much about the research, I will like to just brush up on what I did. I work mostly on microfluidics, microsystems, and currently I'm working on medical devices. So these topics are, if you look at them, they're very different from core mechanical engineering, which we all learn in undergrad. But if you look closely, they're very much related to a lot of things we learn. So when you look at microsystems, to give you an example, human hair is around 100 micron in thickness. So this is how small the systems are which I work in. So obviously I need to use a microscope for these things. When you go to a micro scale, some of the forces which you don't see on the surface become very dominant. For example, surface forces or capillary force, surface tension, these forces are very dominant. In the same way, electric forces are very dominant because electric forces are inversely proportional to the distance between two particles. So when the distance decreases, these forces become very dominant. Similarly, same is true with gravitational force as well. But and another thing is these microsystems are very closely related to our body cells or blood capillaries in our body. For example, since our cells are of the dimension of 100 micron or even smaller, and therefore a lot of microsystems can be used for lot of medical devices. And these systems operate usually in the domain where Reynolds number is smaller than 10, and therefore viscous forces are very dominant in the liquid. And a lot of applications related to micro devices are there in COVID, like the COVID diagnostic devices which you get are micro devices. A lot of devices related to blood diagnosis, cancer diagnosis are related to. So my research used fluid mechanics, material sciences, electrical circuit design, image analysis, a lot of these different areas. I will just quickly tell you about what my research was about. So in my research, I tried to use electric forces and flow-related drag force to separate blood cells and cancer cells. So the motivation here was, if there are cancer cells in a person's body, it is very hard to detect these cancer cells because if you take a blood sample, you cannot find these cells. So we tried to use the difference between the electric properties of blood cells and cancer cells to be able to separate them. And in this method, I had to design these electrodes. I had to use my knowledge of material sciences to build these electrodes. Since I was using a flow-based system, I had to study how the flow profile is going to look inside my micro device. I had to do some computational analysis for it. So I'll just give you, so this is an experiment which was done with bacterial cells. These are not cancer cells. But if you can see that if you use different type of electric fields, these black circles you see are electrodes. And you can see that the different fields, cells will either attract to the electrode or they will repel the electrode. So this is a basic principle which we used. And we also used flow. So by using electric field and flow, we try to separate two types of cells. So in this image, if you think one of the red cell, for example, is a normal blood cell and blue cell is a cancer cell, you can use electric field and flow to combine the effect and separate these two types of cells. And this depends a lot on the frequency you use, the type of electrodes you use, or how you design your electric system. Then, of course, the flow properties in your channel. These are some of the other things which direct the working of the system. And then I wanted to generalize the system. I mean, you cannot just say that, okay, I did this for cancer cell separation and that's it, that's my PhD. So other people should also be able to use what you do, right? So you have to generalize your experience, or you have to generalize what you are doing. And that is where a non-dimensional number is something I came up with. You all know about non-dimensional numbers like Mach number or Reynolds number. Similarly, I defined the non-dimensional number such that you can use a certain electrode geometry, you can use certain flow parameters, and you can use any type of cell, and then you can use that to diagnose the disease. So this is brief information about my PhD project, just to give you an idea of what research is or what type of questions you can answer. So this is a project which I did, but of course this is not a complete device. There are a lot of people in my lab or other labs also who are working on this system. So I came up with I did some research. There are some others who do research. And then all this research combines to get you a good device. For example, it is like dahi handi, a layer upon layer of people, a layer on layer of research, which goes on building till a final device is made. So these are some of the other projects which I have worked on. The first project is again a cell separation project, where we have not used electric field, but we have used flow. So when you have a circular channel like this and you flow blood cells, for example, through a channel like this, based on the size of the cells get separated. So for example, cancer cells have a different size than red blood cells or white blood cells. You can separate them based on the size of the cells, and it also depends on the Reynolds number, the channel parameters, a lot of things are involved. Another thing which I mentioned previously was about blood flow in capillaries. So our body is made up of a lot of capillaries, and these capillaries can be mimicked using microfluidic channels very well. And blood is a very complicated fluid because it's a non-Newtonian fluid. And it is not like water. You cannot use the same equations which you use for water to study blood. You cannot use Bernoulli's equation. So a lot of complications happen. There is a lot of shear force which is there in blood. So we wanted to study how blood clots are formed in patients. And that is why we use microfluidic channel. The third experiment which I have shown here is another research project which I worked on, which is also very interesting. We tried to see how two liquids mix together. So when we are mixing oil and water, water is forming drops inside oil. So by using the difference in the flow rates of these two liquids, you can control the size of drops you make. And I met a person who was working in a factory which makes oil. And he had launched a product of low-fat oil for people, because so many people in US or in general around the world are very diet conscious. So they wanted to have low-fat oil. So this is the technology they use to get low-fat oil. You have these separated droplets. These droplets have surface coating, so they cannot combine. Otherwise, you will get a big blob of water inside oil that is not going to be sold. Like, people are not going to buy it, right? So that is why this was another interesting project where we used fluid mechanics to help a food industry. I will also like to talk about other research projects which were there in my university, just to motivate you or just to help you understand or become curious about research. So this first project is about, I have tried to cover projects from different branches because I don't want only mechanical engineers to be motivated. I'm hoping everybody else also gets some motivation from this. So this is a project. First project is from manufacturing processes. You all must be familiar with forming process, thermoforming or thermal forming. This is a process which one of my friends designed, but this is for doing forming at room temperature. So this process was designed by using a tool, and the tool is moved over a thin sheet, to do forming at room temperature instead. And another
Recording
important point
stopped.
here is mold is not used for such forming. When you do
Recording
forming
in
for
progress.
parts like car console, you end up using molds because you have to do a large scale production. But when you're doing molding or forming for smaller devices, for example, kitchen appliances, or you want to make mobile covers or other smaller devices, you cannot afford to have big machines and you cannot afford to have molds. In such a case, a tool-based forming like this can be used. Another friend of mine, she actually currently works in she actually works with YouTube now, and she's also an Indian student who did PhD with me, but her PhD was in human factors and human computing systems. So she used virtual reality to understand how different people can interact together in a classroom setting. For example, right now all of you students are doing your classes online, but if you have a virtual reality console, you are able to wear that headset and you are able to feel like there is a classroom and maybe Dabir sir is teaching and you can see all your friends in a virtual classroom. Such learning experience can be very, very useful, and that is something she studied. She tried to do a research in this area. She also did some research in social media challenges on YouTube. So this research was related to human factors, which she was also a mechanical engineering student, but she went on to pursue masters in industrial engineering. So this is something which she worked on, and there are a lot of YouTube challenges all the time. So she also did some research on that, which also helped her get a job with YouTube. Another research which my friend did is in origami structures. I think you all might be familiar with origami, which is a craft, Japanese craft of paper folding. But the advantage of origami is made with thin sheets, and this in certain directions they have really high tensile strength. So or compression, sorry, not tensile, compression strength. So these can be used as structural elements. So a lot of designs, I think even spaceships to some extent use origami designs for structural integrity. So lightweight structures can be made with origami patterns really well. So this is something that she's studying. And this is also an interesting research area. I thought I should share it with you. I think even people from civil engineering might find this area very interesting. Another very interesting area, which I think is machine learning. A lot of people nowadays in US, I think virtual reality and machine learning are two really hot areas for research right now. So the machine learning, I don't know if you learn machine learning in your courses right now, but machine learning is something where you can teach the machine based on a certain pattern. So for example, in this project, which also I have taken from my friend, they used some models for buildings and they subjected it to certain hazards like earthquake. And they did some pattern recognition in these buildings, and they saw how the buildings fail, or they saw how the buildings basically respond to these stresses. And this was taught to the software, and this software was used to design further building models. So they're basically teaching a machine to perform further tasks for them. And that's how machine learning is used. And I mean, it is used nowadays in a lot of other areas. This is just an example of how it is used in civil engineering. Some other research opportunities, which I will talk about very briefly, are related to bioengineering, because since I'm working in the area of medical devices now, before I joined US FDA, I was not aware about medical devices because I wanted to be in like pure mechanical engineering. But when I came to know about these devices, when this became a part of my work, I thought it was very interesting. A lot of this work is very cross-cutting. It not only uses mechanical engineering, but it also uses different other types of engineering. So I thought this is some interesting research which I should share with you. First is about additive manufacturing. I think you all must be familiar with 3D printing because 3D printing is a big part of manufacturing industry now. And so 3D printing is used a lot in medical industry. A lot of times the implants, which you see, knee implants or prosthetic arms, prosthetic legs, which can literally give life to a lot of people, are made using additive manufacturing. So a lot of biomechanics, what is the mechanics of human body, how it can be put into work can be studied using additive manufacturing. So this is one example where one of my friends, he worked with creating a model of human heart using additive manufacturing. So initially they do some image acquisition, and there are softwares which can be used for converting this image into an X-ray or a sonography image into a SolidWorks model. And this SolidWorks model can be 3D printed with different type of materials. And this can be used for studying what are the different forces which are applied to human heart.
Recording
so
stopped.
This is useful in understanding heart conditions.
Recording in progress.
Diagnostic devices is another very interesting area, especially for students from electronics engineering. Same with wearable electronics. You all are familiar with the devices like Apple Watch or Fitbit, or there are a lot of devices which are used for diagnosing blood sugar level, even COVID diagnosis. And a lot of these devices directly send message to your phone. They are connected to your phone. A lot of people with diabetes also need to keep checking their sugar all the time. So there are these small diagnostic devices, which are electronic devices, which are also very big area of research. COVID-related research is also very big right now, and a lot of mechanical engineers in US are involved actively in this research. This is a very small example in the type of researches I was involved in. So we were looking at different masks and how the air which comes out of this mask flows around. So we wanted to see if N95 masks or the masks which we use at home are really effective. So we created these human faces, and we put a pipe through them as if a person is breathing, and we subjected it to different pressures, and we used some colored fumes to demonstrate what happens. We also conducted simulations, like computational models for it, and we saw how COVID can affect people, or is mask really effective against COVID? Another very interesting research I would like to share is from virtual reality again. As I told you about virtual reality is used
Recording
in medical
stopped.
industry for a very, very interesting
Recording in progress.
perspective. So a lot of times soldiers who return from border, they suffer from trauma because of the wars they see. So virtual reality is used to come up with games, and then these soldiers wear these headsets and they feel like they are part of the war, and the games are directed such that these soldiers get positive feelings about the war, and they are able to come out of this trauma. Also, small kids who suffer from dyslexia, like you must have seen Tare Zameen Par, a case like that. There are some virtual reality games also for these kids, which can help these kids get out of that condition, or live a normal life. So this is how our engineering research can be used in different ways to help a lot of people. And again, I think Gaurav is going to talk more about the opportunities, but basically there are researches like, American companies and universities have different tie-ups for doing research together. So big companies like Microsoft, Google, Apple, they are always invested in research. They're always sending money to these to universities to get more students to do research. So if you are interested in any of the different technologies or research ideas which I mentioned, I think you should definitely look at these opportunities. Lastly, I would just like to tell you a few points which I learned from people in US and which I feel have helped me become a better person. First of all, in US, people appreciate proactiveness. They like it if you take initiative. If you are a person who is a go-getter, they always like it. So this is something I have learned from people in America. People in America don't like to overdo things. For example, a lot of times I've seen people put big things in their resume, but the actual work is not that big. That you don't see in America. They put whatever is really the work they have done. They're very honest about it, which I think is a very good point about them. Work ethic is really nice about American people. They work they're very punctual, and they are very, very good at the work which they do. They try to, really work hard. But they are also very particular about maintaining work-life balance. They will work hard, but they will also give equal importance to their family, or if they are into sports. A lot of American people are into sports. They like to run, they like to play different games. So they always give importance to these things. Another thing which I really liked about US is the mutual respect they have for each other. For example, when I joined FDA, I was a very new employee, and I met my manager in my first week, and she is actually a big person in American government. She is, I think, just 4 positions below the American president. So she's at a very high post. But whenever she introduces me to people, she always introduces me as her colleague. She will always call me her equal when she's introducing me, though I'm really not her equal in any way. But that is how they always, will show you respect. Another thing is they will never shy away to do any work. I mean, even if we are doing cleaning in the lab, everybody in the lab, like even the professors, they will pick up a broom and they will sweep the lab with us. So there is a lot of dignity in labor, which is seen in US, which I'm still learning. I don't think I have completely learned it yet, but yeah. And of course, there is a lot of importance given to quality of work rather than quantity, because they don't want you to work for 8 hours. Even if you work for 2 hours, but you are able to deliver a good quality, they're okay with it. So that is a very, very good thing, which I like. Americans in general, I think, are very open to different ideas. They like to know about other cultures. In general, people are very open. They want to know about India. They will talk to you about your country, know about your culture. Not just Indians, they will ask the same questions to people from other countries as well. So they are very curious people, and they like to learn from you, which is very nice. They're not close-minded. They won't just say America is great. So, we don't want to know about other countries. That's not the attitude they have. Also, I think soft skills are very important. Something which we don't give a lot of importance to. I mean, as an engineer, I always thought माझ्याकडे टेक्निकल नॉलेज आहे, सो मला काही गरज नाही खूप चांगलं बोलता यायची वगैरे. But one of my professors told me a very good sentence. He told me that when you are watching outside a window and you're looking at a view, you see a very nice view. But when the window is cracked, you are not going to look at the view. You are going to point at the cracks, or you will be looking at the cracks more than the view. It's the same way with language. If you are not able to communicate properly, nobody is going to appreciate your idea. People are going to be stuck at your language. So it is important that you make efforts to improve your soft skills or improve your communication skills. So this is something I have been trying to follow. I wouldn't say I have great communication skills yet, but I'm trying to follow that. Okay, that's it. That's it from my side.